band, because at this frequency band there are less applications. So if you make this design operational at in the range from 2 to 4 gigahertz. Okay.
2.4.
Okay.
2.4 gigahertz.
2
Yes.
2 gigahertz to 4
Yes.
gigahertz.
4 gigahertz.
Not
Yes.
2.4. Okay.
Yes. I will try to shift it. Maybe increase the size of the antenna, so maybe I get the shifted from this way.
And you can also use Roger. Write it down. Roger 3003. Okay. With thickness of
Thickness how much?
of 1.58 millimeter. You can use 1.58 millimeter. You can use 1.52 millimeter. You can use 1.6 millimeter. Okay. So you can use any thickness.
Yes.
Also,
Inshallah, I will.
also check with
Yes.
the Roger 5880. Okay. Roger 5880. Okay. You can use
Yes.
its thickness 0.787 millimeter. Okay.
Excuse me, 7.
Yes, 787 0.787 millimeter. Okay, of Roger 5880. And the
Yes.
other thickness is 0.25 millimeter. Okay.
Yes, I will try to that.
Okay.
Inshallah, I'm collecting all the result. If I send, do you want to send you all the result or just for the enhancement results?
Yes, first enhancement results I want to see.
Okay, thank you very much. Sir, can you please share the link of 21 version of CST? Kindly share.
Yes, I will share, and also you can find, I think, into get into PC, the name of the website. Okay.
Yes, I installed it from there. Sure, sir. Thank you, sir.
Okay. Dear Mr. Tariq, do you want to show me anything, because you are sending me results on the WhatsApp? If you want to show here.
Yes, please, Mr. Ahmed.
Okay, you can show here. Dear Munib, can you rejoin please, so that you can hear our voices?
You hear me, Mr. Ahmed?
Yes, I can hear you.
Okay, like you told me yesterday, we make mini patch here.
Okay.
And make slots in the coplanar here and here, and cut.
Okay.
Small slot here, and put similar like what you say, circle, and subtracted from the main patch.
Okay. And show me the S11. Did you notice any change in the S11?
It's very bad, I think.
Okay. So okay.
But before make the slots, this is the result. After make steps.
Okay, don't worry. Just keep this design safe. Okay, we will. We will make changes.
Sorry, Mr. Ahmed. If I make here slots, is what you think?
No need to make slots here, because they are already very thin patches, so it is not good to make so many slots, because if you make so many slots here, then it is hard to fabricate. Okay, just okay, I want to give you some more suggestion. Okay, keep your design at the side.
Okay, thank you.
I want to take a snip tool, okay, to show you my screen. Yes.
Okay. Excuse me, Mr. Ahmed.
Yes.
I wanted to ask about if I connected the CPU by the background. as one port with the two ports and give the positive port at the feed line. Maybe it's more enhancement. I think it's more enhancement for the gain and more. I get more power.
Mm-hmm.
Also, I want to try when the simulation. I want to replace the 40 replace the 40 by 80 like that in the simulation. Maybe give a more enhancement for more power.
Okay.
It's for good.
Okay, you can add the results in the Word file, and then you can send me the PDF file on the WhatsApp. Okay.
Okay, thank you very much.
Okay, dear Tariq, I want to okay, you need to keep this design safe. Okay, I will give you some more suggestion, because we need to find the novelty factor in your design. Okay, so it may takes time, but you have designed the antenna, but we need to find the novelty factor. Okay, so how can we find it? Okay, now my screen is visible to everyone.
Yes.
Okay, the novelty factor is that what we can do here. Did you use anything on the back side of your antenna?
No.
Okay. Okay, now you can see here, I in the research, nobody has cut this field line from this point. Okay, so you should try this one. Okay, very small. Okay, cut.
From feed line.
Yes, cut this feed line from this point. Okay, from both sides. Okay,
Not much.
as you cut this one. Okay, as you cut this one.
Okay.
So just you need to cut this fill line and see the effect. Okay, I hope this will design will give you some may become circular polarization. Okay,
And it shifting my frequency results.
no, just save it, keep it at 2.45, or if it gives you dual band, then you can. Okay, I prefer you to, I mean, if you see wait a minute, yes, if you notice, it is resonating from in the range 5.8. Okay, at any frequency. I prefer 1.5 gigahertz. Okay, I prefer 1.757. Okay, I prefer 1.8 gigahertz. Okay, or I prefer 2.4. I prefer 2.45. Okay, because applications are available at these frequencies. Okay, while the other frequencies, there are less applications available. Okay, and the other 3.5
for ultra wideband.
for
Until 10 gigahertz.
Okay, we need we want this design for sub 6 gigahertz. Okay, do you know sub 6 gigahertz or sub 5 gigahertz?
Yes.
Okay, so it means it is should be less than 6 gigahertz frequency. Okay, so
Okay.
we will design for this application. Okay, sub 6 gigahertz. Okay,
So you mean from 1 to 6 gigahertz?
yes. Okay, now other thing, also notice this thing. Okay, this is your another task. Okay, we will find the novelty factor in this design so that it will become amazing design, and then we can publish in a good journal. Okay, I am giving you some suggestion just to check what are the changes. Okay, the first thing is this one. Okay, the other thing, you need to create a slots like this, here slot and here slot. Okay, cut this patch. Okay, why we are cutting this patch? Because when we study the reconfigurable antenna, then we will try to connect diodes here. Okay, maybe it will become a reconfigurable antenna.
Yes, it will be amazing idea.
Yes, that's why, and also we can cut patch from here and put diode here. Okay,
Yes. Yes.
so this is what I am thinking to, it will become amazing one. Okay,
Yes.
and also you can try one more thing. You can try a small patch here, a very small patch. Okay, and connect and create another patch on the ground plane. Okay, on the other side, on the other side of the substrate, and connect that patch and this patch with the shorting pin. Okay,
Okay.
and check what are the difference in results. Okay.
Okay. Okay. Thank you.
Okay, good luck. Okay, so welcome to all of you others, and today lecture is all about wideband ultra wideband antennas. Okay. Yes, wideband antennas. Okay, so today we will study about wideband or maybe ultra wideband, it depends. Okay, antennas. And let me check, recording is running. Yes. Okay. Okay, so this is our lecture 6, and I hope you have watched my previous videos of lectures, I mean previous lectures, and I hope you will not have any problem with your designs. Okay, and today we will start with the ultra wideband antennas. Okay. Okay, so we will study this paper. Okay, this is my another paper on a compact CPW fed ultra wideband MIMO antenna for wireless communication networks. Okay, so we will only study about a compact size ultra wideband antenna. Okay, not MIMO. Okay, we will study MIMO in our other lecture where we will study about MIMO. Okay, so it is for wireless communication networks. Okay, so I will this paper is not published. I hope it will publish today because it was accepted, and I hope it will publish in maybe today or tomorrow. Okay, then I will send you the link of this paper. Okay, so we will study this design. This is ultra wideband antenna, and you can see the shape is new and but very simple design. Okay. Okay, so let's start its designing. And first of all, if we want to target this journal, this is the Q1 journal of IEEE access. Okay, IEEE journal, it has impact factor of 3.3 I think 67. Okay, 3.367, and it is a Q1 journal. Okay, and Q1 journal do not accept simple designs. Like if I only publish this ultra wideband antenna, then it is very hard to publish. Okay, but if you discuss 2 to 3 things in your paper, then it is easy to target this journal. Okay, like you have a ultra wideband antenna, but if you also make MIMO of your UWB, because ultra wideband antenna with MIMO gives very good results. Okay, so it is easy to target MIMO antenna with UWB or wideband antennas. Okay, so I will yes, now it is Q2, it is fall to Q2, maybe it will rise again to Q1, I hope so. Okay, so I am telling you that we will discuss when we want to target this journal, we have to show we have to combine 2 to 3 novelties in the paper. Okay, like the first one is the ultra wideband, the second one is the MIMO antennas. Okay, and your brief explanation. Okay, so with only if you suppose if you only target MIMO antenna, then it is hard to target this journal. Okay, so you need to show 2 to 3 things in your design. Okay, so let's start with this UWB design. Okay, you see I have just made a very simple design. What is the size? Okay, let's see its dimensions. And this is a jug shape antenna. Okay, and you can see here what is the length of the substrate. The length of the substrate is where is the length of the substrate? Here I did not add. Okay, so it will be in this portion. Yes, this one. Okay, the length of the substrate is 31.68 millimeter. Okay, and also check the frequency range. Okay, 2 to 12 gigahertz frequency range I have set. Okay, here but UWB antennas works for the frequency band 3.1 to 10.6 gigahertz. Okay, this is a UWB spectrum. Okay, but mostly people like to have frequency range from 3 to 11 gigahertz. Okay, 11 gigahertz. Okay, so let's start this designing. We will study the slot, dear Ambrish. We will study how can we create slot at an angle of 45 degree. Okay, so I am setting range here 2 to 12 gigahertz. Okay, and since it is a wide band, so I can take many samples here. Okay, like 3 4 5 6 7 8 9 10. Okay, 11. Okay, it will give me samples, I mean results of E field, H field and far field at these frequencies. Okay,
Excuse me, sir. Does wideband have a certain spectrum like UWB?
no, actually wideband this is a UWB spectrum. Okay, but the wideband like you have a frequency band. Okay, like you want to target 2.45 gigahertz, and but the your antenna is below minus 10 dB. You can see here it is minus 10 dB line. Okay, and you want to operate your antenna at 2.45 gigahertz. Okay, and you notice that your antenna starts from this one and resonator this one and like this. Okay, so this is, you can say, this is a wideband antenna. Okay, that covers much bandwidth. Okay, like you have here 1 gigahertz and you have here 5 gigahertz. Okay,
Right, sir. Thank you, sir.
okay, so start this design first and let's see its results. Yes.
Can you please share my screen?
What?
Can you share my screen to show you something?
Your screen?
Okay, 1 minute.
Do you want to?
I can share my screen.
What do you want to present?
I have previous ultra-wideband antenna, new design. I make for.
Yes, but I prefer if you show us tomorrow, because tomorrow we have a session to show us the design. Okay. Okay, because today I will teach you and tomorrow you will teach me. Okay. Okay, so now the length of the substrate I have used here FR4 substrate. Okay, sometimes the reviewers ask you to shift your paragraphs. Okay, like this, because I wrote this paragraph in this section, but the reviewer has asked me to change it. Okay, so we have used FR4 substrate. Okay, and I'm going to use here as substrate. You can only write sub. Okay, and width of the substrate. Okay, length of the substrate and the thickness of the substrate. Okay, so what is the width of the substrate? The width of the substrate is 23.76. okay, there are a lot of antennas on UWB, so people researchers now are working on its compact size. Okay, to keep its size very compact. So it is better if we target this UWB band with very less small size. Okay, 31.68. okay, and the thickness of the substrate is 1.6 mm. okay, and FR4 substrate. Okay, we have this FR4 substrate. Okay, first we have to create this CPW. Okay, a ground plane. Okay, what is the length and width of the ground plane? LG here, you can see here. Okay, I shift my WCS at this point. Okay, this is left CPW. Okay, so I'm writing here CPW L. Okay, left. Okay, and I need dimensions in the U direction, I mean Umax and Vmax. Okay, so I'm writing here WG. Okay, and in the upward direction, what is your question? At which frequency you design in this UWB range? I did not understand what you mean, because the band is below minus 10 dB, so there are a lot of frequency bands covering in this range. Okay, so you can say your antenna is not exactly at 5.6 gigahertz, but if it is below minus 10 dB, so it means it is covering every frequency band. Okay, if you see, it is working at this, there is a this one, and this one is more prominent. Okay, so at 3.5 and 8.5, okay, gigahertz. Okay, anyway, the main thing is to learn this design. Okay, and okay, so WG is the width of the ground plane, that is 10.85. okay, right here LG. Okay, and thickness of the patch. Okay, and copper anneal. Okay, now click WG is the width of the ground, that is 10.85. 10.85. Okay, and the length of the CPW is 12.14. okay, 12.14. okay, and the thickness of the patch is 0.035. okay, as I told you in the previous lecture, copper is available of thickness 0.0175. okay, 0.035. okay, and 0.05 millimeter. Okay, if you are working at millimeter waveband, then I prefer this thickness. Okay, but in normal cases we mostly use this one. Okay, this thickness.
Mr. Ahmed,
Yes.
why you always prefer CPW in all designs?
Okay, CPW actually helps you to achieve the more bandwidth. Okay, it depends on you, if you want to use partial ground plane, whatever you want to use. Okay, it's up to you, because I like to I like to use CPW. Okay, because it is easy to handle the frequency band using this CPW technique. Okay, so you can easily handle, if you suppose, if you increase this length of the ground, then your frequency will shift towards the higher frequency. Okay, if you reduce this length of the ground, then your frequency will shift towards the lower frequency band. Okay,
Okay, thank you.
okay, so this is CPW, right? Okay, and the U in the U minimum minus WG. Okay, and upward direction LG, and the TP. Okay, thickness of the patch. Okay, okay, so what is the thickness of the field line, width of the field line, and length of the field line is 1.58. okay, 1.58 millimeter width of the field line, and the length is 14.65. okay, so in order to field line, starting from the center, so you need to shift your WCS at the center. Okay, feed line minus WF by 2. okay, LF TP. okay, width of the field line is 1.58. okay, and length is 14.65. 14.65. okay, okay, so this is a field line. Okay, so now the next step, we will follow this patch. Okay, first we need to make this one, and then create slots like this. Okay, So first we need to create a patch, okay, of size of length 16 millimeter and width 10 millimeter, okay. Okay, so we need to start from here, okay, from here, okay. Patch, okay, and I am writing here WP by 2 and minus LP, okay. What is your question? Width of the field line is standard or need to optimize according to design? You need to optimize according, yes. I just choose 1.58 because in CPW in most of the cases when you have a field line at 1.58 millimeter or 1.6 millimeter, then it is you can set your impedance, okay, for impedance matching, okay, you can say. But you, if you want to another width, you have to uh, uh, vary this gap according to the matching impedance, okay, for to set at 50 ohm, okay. Okay, so here what I will do, WP is the 10 millimeter, okay, and LP is 16 millimeter, okay, yes, okay. So this one, and here if you notice, so I write here minus TP, okay, because it will be under this, okay, like this, minus CP, minus TP, okay. Okay, okay, now the next step is to cut the edges, okay. You can see first you can cut from this point, okay. I will cut it, or I am just pausing my own values, okay. Okay, so I need to connect this both, okay. Okay, now I need to cut from the both side, okay. Okay, cut patch, okay. So here, okay, here I choose here minus 1, 0.1 millimeter and minus 1, okay, to just check the values, okay. Okay, in most of the cases we take 0.2 millimeter because the fabrication machine cannot create slot less than 0.2, okay, millimeter, and minus TP, okay. And on the other side again 0.2 and minus 1, okay.
Mr. Ahmed, the machine here, it can't cut less than 0.2.
Yes, cannot.
So the maximum is minimum is 0.2.
Yes, I think yes. I will confirm either it is 0.2 or 0.02, okay. I forgot, but I think it is 0.2, yes.
Okay, okay.
Okay, so we will cut this patch, okay. Where is the patch? I write here patch, okay. Minus, I'm clicking minus button on the keyboard, selecting this one and this one, okay. Press enter, okay. So you can see now this is cut here, okay. Okay, so I am now, I need to cut, need to make this shape, okay. So how can I make this shape? First I need to uh, set my WCS at the center of this substrate, okay. Okay, now I want to cut these slots, okay. so I use this one. Okay, so if you zoom it, then you can easily pick the points, okay, more accurately. Okay, so you need to come here at this point, so you need to select the middle point. Okay, mm, wait a minute. So there is a gap between this one. Okay, so it means it is not at the center. Okay, so press escape button to cancel this one. Okay, now pick again. Okay, so my value will end at this point. Okay, so how many boxes, mesh boxes are inside? If I want to 1 2 3 4 5 6, okay, so I need to create this point. Okay, I mean select this point. Okay, how many boxes are covering? Okay, so I suppose I'm choosing this one. You need to create all for only one time, no need to create many times. Okay, like I am making this shape one time, then I will use in the whole design. Okay, how will I use, and I will show you. Okay, okay, minus TP. Okay, you need to check whether it is inside or not. Okay, so this is inside. Okay, now I will use this cut on the whole design. Okay, okay, so you can see here, first you need to shift your, make a copy, create a copy. Okay, and transform, you can select this one. Okay, like this. Okay, you need to transform this at the edge. Okay, on the other edge. Okay, you need to click copy and press OK. Okay, so you have two different. Okay, this one like this. Now you need to if you want, you can create a new one here. Okay, new triangle here, new triangle here, but if you don't want, then you can copy this one and paste and turn off and paste there like this, as I'm going to show you here. Okay, like this one, just turn your,
or Mr. Ahmed, you can mirror it.
yes, I am rotating now it. You click on it and you click on the copy first and then click on the rotate. Okay, so you need to pick this point. Okay, like this. Okay, like this, you can see you need on the other side. Okay, like this. Do you understand? It is 180 degree. Okay, so now click OK. Okay, so you need to check whether they are good, correctly placed or not. Okay, so you need to check. So this is above copper. Okay, so what you need to do, you need to select this one and this one. Okay, and you need to shift it down. Okay, you see this is above copper, not inside copper. Okay, so I need to shift this one in the copper, or you can write here minus TP. Okay, minus TP. Okay, press OK. So this is inside copper right now. Okay, so you can see. Okay, now I need to select this copper. I am pressing minus button on the keyboard. Okay, now I am pressing control button on the keyboard. Press control button, select this, select this, select this, select this. Okay, I have selected all these slots. Now I am pressing enter. Okay, so you can see you have a shape. Okay, like this. Okay, I have a shape like this. Okay, the other thing, I think I have the thickness of the substrate is wrongly written here. Thickness of the substrate, where is thickness? I think it is more. Okay, so I want to create a handle. Okay, sorry, first I want to create this patch on the top side of this patch. Okay, so I will convert my CS at this corner. Okay, and you see there is a gap, okay, like this. So I create a circular patch here with cylinder. Okay, I am writing, if I am checking where it is. Okay, and okay, so you can see here there is a gap. Okay, but you see this is not exactly at the center, there is little shifted above. Okay, so I need to shift patch little shift above. Okay, minus 0.5. okay, I think 1. Yes, okay, now I press minus TP. Okay, like this. Okay, now I am combining this patch with this circle patch. Okay, now I am pressing shift plus button on the keyboard. Okay, now you see this is now one patch. Okay, the other thing, I need to create a handle. Okay, this handle. Okay, so how can I create this? Okay, align your WCS on the substrate. Okay, this one and this one same. Okay, now I am going to create a handle here. Okay, I use this one, this curves. Okay, so how can I create a handle here? Like this one, I am clicking on this edge. Okay, I have clicked this edge. Okay, so you can see, and I am pressing here. Okay, how many? 1 2 3. Okay, 1 2 3. Okay, at this point. Okay, now combine both the points. Okay, like this. Press OK. Now I am writing TP to check. This is inside patch. Okay, so sorry, below patch, so I need inside patch, so I am right here minus TP. Okay, so now both are together. Okay, like this. Okay, so now what I will do, I need to select this one, this patch. Okay, I am going to create another yes, another handle. Okay, like this. Okay, I am creating another handle. Okay, I combine both the points. Okay, click OK, and now press extrude curve. Okay, double click and check where is this. If you write TP here. Okay, so this is inside. Yes, click OK. Now you can see here. Okay, so I first click the bigger handle and press minus button on the keyboard, and then select the second one and press enter. Okay, so you can see here there is a handle here. Okay, Now you can combine this handle with the patch. Okay, now I press shift plus. Okay, okay, now you can see your design. Okay, it's okay now. So you need to assign port here. Okay, okay, first if we want to use it with the formula, then we need to check the width of the field line and the gap. Okay, this gap is 0.024. Okay, okay, now I am selecting waveguide port. Okay, now I use here 2. Okay, WP plus 2. Okay, gap like this. Okay, so I did not define the gap here. So when you click on the preview, it will ask you what is the value of the gap. So you can write here 0.24. Okay, just copy it and paste on the other one. Okay, paste everywhere. Okay, in the downward you need to write 1. Okay, 1. Okay, click on the preview. Okay, this is very big port. Why is this big one? Okay, sorry, I use WP. Okay, okay, now I'm press preview. Okay, so this is your port. Click OK. Okay, so now this is your port and you will simulate this design. Okay, also you can click on this one, normalize to fix impedance. Okay, so did you understand the procedure of this design? In this way you can make any shape. Okay, make any new shape, whatever you have in your mind.
When you at the first when you see the design, you will say that it will be difficult design, and when you design it, it's very easy.
Yes, it is easy. So in every paper you need to add the design steps. Okay, as I have added in this paper. Okay, like this one I created first patch, and then you notice the S11 behavior. Okay, like this. This is your A, and you can see aunt one. Where is your aunt one? Black one. Okay, so you see it is not wideband at this position. Okay, this is above -10 dB. Okay, so you need to do this optimization. Okay, design steps, and you need to check this one. Okay, I made this graph in CST. Okay,
Mr. Ahmed, can I ask?
yes.
Mr. Ahmed, when do Boolean operation like subtract or add shapes, how to separate these shapes without lose other modification?
Actually, in some of the cases you can separate them, but in most of the cases you cannot. Okay, when you edit them. Okay, if they are like if you are adding two different patches, and you are able to separate them. Okay, like if I want to separate many shapes here, if I click on the separate shape, then it will not separate things. Okay,
Yes. So there were no way.
no way you need to redraw the shape or create a new you need to create that shape that you want to separate. Okay,
So you have to return how and do everything at first.
Yes.
Okay. Okay. Thank you.
So it is better if you uh, keep the files save, I mean, in the first file, you when you create this circle, create this patch, create this slots, create this handle, okay, and create this field line separately, okay. Keep this that file separately, and in the second file you can add all the patches, okay. If some of you want to target this journal, and I will guide you how to target this journal, okay, but you must have some good designs, okay, that have some good results. I This design is simple, but it is very compact as compared to the previous research, okay. And also I made this MIMO antenna of this design, okay. So it is better whenever you design a wideband or ultra wideband, then I suggest you to also uh, add results and of MIMO antenna, okay.
Because I think it's difficult to publish in the IEEE.
Not difficult, you know. My paper, this paper is accepted 2 days ago, just 2 days ago.
That's good.
Yes,
That's very good.
that's why I told you I hope this paper will be published today or maybe tomorrow. They take some time, okay.
But I think you must to be member in IEEE.
No, it is not necessary. I am a member, but I am a student member, okay. Even if I cannot, I do not add this one, then it is not. But your paper must be, I mean, good written, and there should be one or two senior member of IEEE, okay, like this.
Yes.
uh,
Okay.
some people like to have a member of IEEE to get discount, okay, in the fee, because the fee of this journal is 1,750 US dollars.
Wow.
But if some of you prepare good designs and good results, then I can provide funding for this journal, don't worry.
Okay. Thank you.
Okay, let's check its S11. Okay. Okay, so you can see here there is a this part is not below minus 10 dB, okay. Okay, so you need to do some modifications in the design, like if you notice this handle, you need to create it you need to make it more thick, okay, like increase width, okay, or you can do it with this curve tool, okay. Again, okay, at this frequency band it is wide band, okay, at this range. Like you can increase the size of the handle, okay, because in this design I noticed that there is a major contribution of this handle, okay, to make create a wide band, okay. And also this design is circularly polarized, but I did not add in the paper because it is not circularly polarized at all the frequencies, okay. It is circularly polarized, but not all the frequency, at some frequency bands. The main thing is to learn different shapes and the results you achieve, okay. When we learn different types, then we will suppose we have different types like wideband and MIMO. If we, as I told you in this paper, I have ultra wideband and MIMO. I am combining two types of the antenna, okay, MIMO and wideband. Okay, in this way, if we combine any two types, then it will be easy to target any good journal. Okay, like this metamaterial base and wideband or flexible, or okay, you can do any, you can mix any field together. Okay. Okay, I am taking its more values. In the first attempt you never be able to achieve the same results. Okay, so you need to modify your design accordingly.
Why did you mention the dimensions of the handle in the paper?
I added, I think, yes, this I added in the paper.
Okay.
I am just drawing. I mean, the main purpose is to teach you how to design and to achieve wideband. Okay, because I told you, in order to design anything, you need to first follow any paper. Okay, you need to target one paper. Like I am targeting this paper, and I know I have a shape like this. Okay, and you in the paper you even cannot, if you even draw shape with same dimensions, you cannot be able to achieve the same exactly the same results. You may have some difference in the results. Okay, maybe because of CST1, maybe because of the mesh cells. Okay. Okay, if I need to increase the length of the ground. Okay, also I noticed thing that by increasing the length of the ground, my antenna shows more wideband. Okay, and also here this is very close. Okay. Okay, now simulate. So you have any question regarding to previous lectures or this lecture?
Sir, have you written this article on MS Word or in by using latex?
I don't prefer I mean I use Word, but I do not suggest you to use latex because there it is very time consuming. Okay, so let's discuss few things about this paper. Okay, I mean the writing way and other things. Okay, in the literature view, like in introduction you add the literature view and the I mean introduction and literature view. Okay, like I have one paragraph on the UWB. Okay, like in yeah, okay, I have one paragraph starting from this to this, the only about introduction of the UWB, what is UWB and where we use this UWB. Okay, ultra wideband is a technology in a telecommunication, okay, that enables high speed bandwidth connection with the low energy consumption in wireless communication networks. Okay, and then I will add its benefits, what are the benefits of this UWB band if we achieve this one. Okay, and when it is launched like this. Okay, you will discuss some history, okay, like 1 to 2 sentences, and then you will discuss about its benefits. Okay, and why you use this, because of in this paper what is the main contribution and what has been done in the previous research. Okay, then when you will also compare the papers that has previously done. Okay, this is the literature view, okay, in which you will discuss about the size of the antenna and the band they have achieved, and the how much gain they have achieved. Okay, and which substrate material they have used, and what is the I mean drawback. Okay, you need to also need to mention the drawback in the previous research, because you are now targeting your own, and you want to compare your results with the previous research. Okay, you need to create a table, okay, of latest papers. Okay, these are all latest papers of 2020 or 21. Okay, you need to compare your results with the previous research, what you have achieved, and if you achieve, suppose you only have achieved the compact size than the previous research, then it is able to publish. Okay, with more things like you have achieved more bandwidth. Okay, or you have a very compact size, or you have a good isolation. Okay, or you have a good efficiency, then in this way you can defend your design. Okay, so in one paragraph, like this, I mean, you need, in the literature view, you need to discuss about 15 to 20 papers, or maybe 25 papers. Okay, if you want to target this journal. Okay, like and one paper, you will discuss one paper in one paragraph, or maybe 4 to 5 sentences, like like you can see here, this is combination of two papers. If you have the same results or same thing, then you can write side two papers together. Okay, sorry.
And these references will be must from IEEE.
Yes, let me explain. Wait a minute. There is one person. Hi dear Suleiman, can you introduce? There is much distortion. Can you write please in the chat box? Did you register for the, or you are joining from another account? Okay, Mr. Tariq, yes, if you want to target any journal, you need to cite, or you need to compare the papers of that journal, like of IEEE access. Okay, like in the, please turn off your microphone.
Assalamu alaikum. Assalamu alaikum. Professor Rush. Assalamu alaikum.
Wa alaikum assalam.
I am Muhammad. Excuse me, Professor,
Okay.
because I have 2 days in my laptop in my school. I have a problem in mic.
Okay, no problem. Just turn off your microphone. You have any question?
No, I use mobile because I have a problem. Yes, in the mic. I don't know what happened to the
Okay,
computer.
okay, don't worry. Just turn off your microphone.
Okay, because I just use it. Yes.
Okay, no worry, no worry. Okay, whenever you target any journal, you need to cite at least 3 to 4 papers of that journal. Okay, of IEEE access. Okay, like I have this IEEE access and other IEEE access. Okay, like this.
And the first reference will be must from IEEE.
I did not understand what you mean.
The first references. The first reference
No.
must be from IEEE access.
No, it is not necessary. Like the first reference should be from IEEE. It can be IEEE, but of any journal, okay, like IEEE other transaction, or IEEE AWPL, or many other journals, okay. But you can also cite other journals, it is not a problem. But I mean, whenever you target any journal, you need to cite 3 to 4 or 5 papers of that journal. Like I want to target IEEE access journal, then I need to cite 3 to 4 or 4 to 5 journals of IEEE access, okay, that is published previously.
And how to avoid plagiarism from introduction? We have always problem with the plagiarism.
Okay, I will.
Introduction.
Okay, I will tell you. Okay, now did you notice if I increase the handle, and the UWB is now, you can see here, it is now very close to -10 dB. Okay. Okay, there are actually many ways to reduce the plagiarism. Okay. Okay, I will tell you how to remove the plagiarism, or how to avoid plagiarism. Okay, when we start the, actually there are very short tips for writing research papers. Okay, I will briefly explain in this session writing research writing tips. Okay. Because many people face this kind of problem of plagiarism, okay, and even don't know how to write a research paper, and how to complete research paper in less time. Okay. There are so many shortcuts to tell you, but I will briefly explain in this session. Okay. But for the plagiarism, I can suggest you some websites. Okay. Only one website. Okay. The name is Quillbot. Okay, you can use this tool. Okay, but okay, actually there are so many tools for writing rephrasing, or to removing the plagiarism, but this is more authentic, because if you suppose in the I write here article rewriter, you can see the difference in the other softwares. Like I copy one paragraph. Okay, I write paragraph here. Okay, you need to fill this captcha.
Actually, brother Sarush, I want to tell you something. Not avoiding the plagiarism is a target, because sometimes if you avoid the plagiarism, you know, sometimes a scientific sentence become
Yes, yes,
become
I am going to just explain right now. I am just explaining this thing. Okay. I am explaining that if you target other websites, like this website, this is the article rewriter tool. If you paste here, and if you read both paragraphs, this paragraph and this paragraph, you will find a huge difference. Okay, you will not understand what you want to say. Okay, and it will totally change your sentences and the meaning of your sentences. Okay, so that's why I do not, yes, this is what I am saying. Okay, so I do not prefer these tools. Okay. But I only suggest you this tool. Okay, this is more authentic to only for the researchers. Okay. Because if you paste any paragraph here, it will totally understand your language and your meaning, what you want to say, and it will paraphrase your paragraph in a very well manner. Okay, like you see, if
also
yes,
yes, also plus also in the word also we can paraphrasing
yes,
some words, like a synonym word or something. Just right click in the word, you can change, because sometimes they count some words next to each other, and they detect the plagiarism directly.
yes, yes, it is possible. And also this is a good website. Even if it shows any plagiarism,
Yeah, I
you
know
can.
it. I know it. Sometimes I use it, but sometimes the sentence from the scientific word become little weak.
Yes, yes. So at that time you need to you can use like this one. In this way you can use synonyms, or you have to paraphrase by your own self. Okay.
Yes.
But I
Yes.
prefer to do it ourselves because these tools are not very 100%, you can say, trustable. Okay.
Sure. Sure.
But it will help you how to paraphrase these things. Like you, if you once you have converted this paragraph, and then you can again you can again tune this your paragraph. Okay.
Mr. Ahmed, even I use these tools, I always find plagiarism in my paragraph.
Okay. Actually, many ways to writing the research paper, okay, to avoid plagiarism, because plagiarism is the main target of the.
How much percentage from plagiarism is acceptable?
It should be less.
Less than 20, like.
It should be less.
Less than 20 is good.
It should be less than 15%. Okay.
Maybe some schools or some journals, maybe it is according to journal or what?
Yes, most of the journals accept plagiarism less than 50%. Okay. Because IEEE accept less than 15%. Okay. And other journals also, if you even you have a 12%, then they will ask you to reduce more plagiarism. Okay.
Because sometimes when put this paper in like turn it in or to check plagiarism, even the title or the title of the journal he accept as plagiarism.
Oh,
you need to exclude
yes.
it.
You no need to worry about the title, but you have to change the paragraph in. Also, you need to disclude these references. You need to disclude these references in the plagiarism.
Okay.
This thing.
Also, Tarek, it is better for you to before you're putting in the journal format, you can check the plagiarism to avoid this point. Okay.
Yes.
You don't need to become worried after that.
Yes, because when you check the plagiarism with any software, let me show you any of. I don't know here.
But brother Sarush, I want to ask you about Turnitin or ISA indicate. I use both. There is a difference.
I also use both.
There is a difference, almost maybe around 5%.
Yes, I use Authenticate software. Most of the journals use this software, and some use Turnitin software.
ISA indicate, yeah.
Yes.
Thank you. I have access in it. Only six paper, and I use it.
So the main target is to design, and I hope you will design a very good shape, because we have very less time. If you start from now, as Tariq did, we can target journals very easily. We can start our work very soon. Okay, not after this month and other month like this. Okay, so I want you to start work on designing, and you need to make a good shape and good results, achieve good results, so that we can target and decide where we want to submit, or which journal we want to target.
But Brother Sarush, about IEEE access, is easy now? I think it become very difficult.
Yes, it is difficult, because IEEE access rejects your paper in the first attempt. Okay, in the first submission. Okay, it always rejects your.
I take three round. I take 3 round. It will be accepted.
In my both IEEE journals, it takes to only, first round. Okay, in the second round it got accepted.
I don't know, but access become a change now, I think.
Yes, it is going hard, and also IEEE transaction is going very hard now.
Yes, the transaction, of course, they need a very, very high novelty.
Yes, I am just leaving other journals. That's why I want to make a research group, so that the other people work with me to target other journals, and for my own journals I want to target IEEE transaction, because it takes a lot of time, maybe 1 year to write one paper.
But the IEEE is later, take 1 month.
Yes, writing paper, not review.
Not writing a paper, yeah.
Yes, also to prepare a good design. Okay, because the novelty is the main thing to prepare a good design.
Yes.
Okay, so you need to modify many things. Okay, I also want to show you the axial ratio. Okay, like this is the circularly polarized antenna. Wait a minute. Okay, Now you can see here what is the axial ratio, and it is just below 3 dB. Okay, so let's find the other, check at the other frequencies. Okay, now you can see this is below 3 dB. Okay, axial ratio is below 3 dB. Okay, you can take this one, or if you want you can take this one. Okay, so this is approaches to 0 and it is below 3 dB. Okay, this is circularly polarized antenna at frequency of 5 gigahertz. Okay, so let's check the surface current at 5 gigahertz. Okay, now you can see your current is moving in the circular pattern. Okay, in the patch it is moving in the clockwise direction, while in, if you see, it is showing like this. Okay, you can see your arrows are moving in the circular round. Okay, can you see? So it is a circularly polarized at the frequency of 5 gigahertz. Also it has axial ratio less than 3 dB. Okay, like this. Okay, the other thing, how to calculate the graph, I mean axial ratio versus frequency graph, because this graph is not a axial ratio versus frequency graph. Okay, but this is axial ratio graph. Okay, so how can we achieve that graph? So in CST, if you you need to check first the axial ratio, phi is equal to 90. Okay, you see phi is equal to 90. Okay, and what is the theta? This is your theta, horizontal axis is your theta. Okay, so you need to check where is the deeper value. Okay, it is deeper at 128 theta. Theta is equal to 128 degree.
And how to check axial ratio versus frequencies?
Yes, I am going to show you now. I am telling you that you need to first keep in mind these things. Okay, that your axial ratio is below 3 dB and the deeper value is at 128. Okay, theta is equal to 128. Okay, and the phi is equal to 90. Okay, so now you need to go to the post processing and then go to the result template. Okay, click on the far field.
Why you choose phi 90 degree?
Okay, now if I change the phi, let's see what will happen with the axial ratio. So you can see this is not below 3 dB. Okay, at 90 degree, phi is equal to 90, it is below 3 dB. Okay, okay, now go to the post processing, click on the result template and click on the far field and antenna properties. Okay, then go to the far field result. Okay, and then go to the here. Okay, maximum gain over frequency, go to the setting. Okay, now you can change here. Okay, realized gain and the axial ratio. Okay, you can see here axial ratio. Okay, and click on the broadband, and now you need to click on the single direction. Okay, click on the single direction. Okay, now you need to write the values here that you remember. Okay, in single direction, what is the value of the phi? It is 90. Okay, what is the value of the theta? You notice at which the axial ratio is below 3 dB, it is 128. Okay, so now click on OK and click on the evaluate, and it will show you the graph of axial ratio versus frequency graph. You can see here it is only checking axial ratio.
I want to ask you about the equivalent circuit for ultra-wideband.
For the equivalent circuit, I did not design in this software. It is designed in ADS and AWO.
Totally difficult other than the multi-band or single band.
Yes, it depends on the structure of the design and the operating bands.
Yes, to select the lambda element.
Yes.
Even in ADS or microwave studio, I tried many times actually. I don't know how the researchers do it.
I will try to arrange a seminar, okay, on it, because in this session we will not study equivalent circuit. We only study the circuit, antenna designing. But I try to arrange the seminar, okay.
But no, for design is something easy. It does not take time for the thing for narrow band or something like this.
Yes.
Or even multi-band. For ultra-wideband, because we have a wide range.
Yes, it is difficult in UWB.
Yeah.
Okay, so now you can see here at the frequency of 5 gigahertz it is below 3 dB. Now this is the frequency versus axial ratio versus frequency graph. Here in the vertical axis you have axial ratio, and horizontal axis you have a frequency. Okay, and you can see here at these frequencies it is below 3 dB. Okay, so in this way you can calculate the axial ratio versus frequency graph. Okay, and also you can add this picture in this figure. You cannot add the other contour like this. Okay, you need to add the arrows to show if they are moving in the circular pattern. Okay,
and for the gain, how much is the gain of voltage sampling?
Okay, let's also calculate the gain. Okay, okay, now click on the realized gain and broadband and click OK. Evaluate. Now it will calculate the realized gain versus frequency graph at the all the frequency that we have monitor. Okay, at 5, 6, 7, 8, 9, 10. Okay, so this is the realized gain. Okay, at the frequency band. Okay, it is above, yes, it is almost, it is 1.76 okay dB at 3.15 gigahertz, and it is varying. Okay, so if you in the when you starting the file, I wrote many times where you set the range of frequency. I wrote 2, 3, 5, 6, 7, 8. Why I use? Because it is taking samples at only that frequency band, like at 2, 3, 4, 5, 6, 7. Okay, if you write more samples like 2.5, 3.5, 4.5, then it will show you more samples. Okay,
and this again is acceptable.
You need to compare with the previous research. Okay,
okay,
if your gain is or very close to them or higher, then you can defend your design. Okay,
but actually, brother Saruj, we need to compromise between the gain and the efficiency, because you know the relation between all them.
Yes,
sometimes it's a very difficult issue.
Yes, in the previous lectures I explained that if you have a efficiency, linear efficiency that is very close, should be very close to the total efficiency. Okay, radiation and like this, it should be like this.
Between the gain and the efficiency, you need to compromise this point.
Yes, and it is starting at this 3 gigahertz. It is more than 90%. Okay, and it is you shifting to the lower. Okay, so you have any other question?
I want to ask you something. Actually, I have experience in ultra-wideband, and I'll show to you tomorrow, inshallah, many papers. But I want to ask you, sometimes when I design ultra-wideband, it was maybe 2 years ago or something like this, I always change the center frequency for designing at the beginning. You know, we have equations in Balanese book or something like this.
Yes, we have.
But there is no specific frequency in this wide range. We can admit it.
Actually, when you have a wide band or ultra wideband, then you need to take the lower frequency band. Okay, like you have a antenna starting from 3 gigahertz to 11 gigahertz, then you need to take the lower.
Sure. I know, brother, but if I select this lower band, this means, you know, we have like reciprocal between the size of the antenna and the frequency.
Yes, you're right, because if you
proportionally difference, the size will become big.
Yes.
But our target to miniaturize it.
Yes, this is the main target. That's why I told you instead of following the mathematical equation, I prefer to read research paper and read how much size they have achieved. Okay.
Of course, for example, if I select the designing or mostly about maybe 4 gigahertz or 3 gigahertz, the size of antenna it will become, for example, my target always I design around maybe 6, 7, 9.
Yes.
I get use that. It has a good result, no problem. But there is no rule. I don't see it in any paper.
Right.
Because some people said we can take the mid range. 3 minus 10 or something like that over 2, and you can select this frequency and you can little shifting it.
Yes, but in this case you cannot you have a wide band, this is starting from 3 gigahertz to 11 gigahertz. You need to subtract this 11 gigahertz from 3 gigahertz, like you will get 8 gigahertz, and then you need to divide the most lowest frequency band. Okay. In this paper, I mean in the case of the lambda by 2. Okay, like this.
Lambda by 2, but you start at a lower frequency.
Yes, guided wavelength.
Ultra-wideband.
Yes, in the case of light guided wavelength, like in this case, you suppose you have a design like this, has a size of 150 cross 75, and it is operating at these frequency band. Then you need to take the most lower band, okay, and it will give you the guided wavelength. This, okay.
Yes, thank you.
Okay, good luck.
Sorry, Mr. Ahmed, can you return the table?
Yes.
Why you choose the dimensions of antenna with the millimeter and lambda G?
Actually, here the millimeter is the physical size of your antenna, okay, while this guided wavelength tell you the electrical wavelength. It do not include the substrate, okay. It only include the epsilon, relative permittivity of the substrate, okay, and the electrical size length of this radiator, okay. This is the electrical size of the antenna, okay, while in millimeter it is the physical size of the antenna, okay, including the size of the substrate.
So we must always compromise to the
Actually,
dimensions.
yes, but actually some papers, some journals like IEEE, it will ask you to include the guided wavelength, okay, because the size in the millimeter is not same as in the guided wavelength, okay, because some designs looks very large in size, but their electrical length looks very small than the previous research, okay. So in this way, you compare your results, you calculate this guided wavelength.
Because it actually something like the normalizing thing, yes. It's something similar like this.
Yes.
For comparing. The reviewer for IEEE said that. You are right, totally.
Yes, actually, most of the reviewers in IEEE ask for this one.
They asking the electric wavelengths here.
Yes.
We can find this formula in Balanese book also, it's written here.
Yes, we can find. Okay, so.
And for what frequency we must choose?
The lower frequency.
Yeah, okay.
Okay, so this is the formula, okay, to calculate the guided wavelength.
Okay, thank you.
You also need to know the epsilon relative permittivity of the substrate. Like for the FR4, if you click, you will find epsilon value 4.3, okay.
Brother, actually, we have a request to you, if it is possible.
Yes.
If it is possible, if you can guide us to the substrates and the frequency range, and also the commercial thickness. If it is possible, if you have a PDF file from something or something like this.
Which type of substrate you want to know?
Yeah.
I mean the name. Okay, I tell you some of the substrate here that I have used. The first one is the FR4, that is most widely used substrate, okay, that has the relative permittivity 4.3, okay, and the thickness is available of 0.8 millimeter, okay, but it is very less, okay, and the 1.6.
You said that.
Yes, 3.2, okay, 3.2 millimeter.
This is standard, yeah.
Yes. Yeah. Okay, the other one is the Rogers, okay. In Rogers, in most of the Rogers are of the same size, okay. If you are talking about the 5880, okay, it has the relative permittivity of 2.2, okay, and it is available of size 0.125 millimeter, but very less, okay, but the most widely is the 0.25, okay, for 2.54, okay, and
0.5.
0.254.
Yes. And Rogers, I can use it for super wideband. Sarosh, it's accessible maybe till maybe 25,
Yes,
maybe 28
yes,
gigahertz.
you
Can
can
be
you
accessible.
can use these Rogers at any frequency band, okay, at also
And
4
also,
millimeter wave band.
and also 0.508.
Yes, 0.504
508.
milli. Yes,
08 to 04.
yes, I think 04, maybe 08, okay. These
And for Rogers, for 1403 is available.
wait a minute, which one, Roger?
Rogers 14, 4003, 4003.
For 4003, you mean? Yes, it
Yes.
is available. I think it is available of 1.57 millimeter. Yes,
Yes, we use it. Use it.
yes, and also 6002. Okay, this is available of size 0.76 millimeter.
This also for same frequency, maybe till maybe 30, 35 giga.
Actually, if you want to move at the high frequency band, you need to check which substrate materials are available with the less thickness, okay, so less thickness available material are suggestible, okay, so you can use any Roger material, okay, and also Roger 3003. There are two type of 3003, and the other one is 3003C, okay.
Yeah.
3C, and it is available of thickness 1.52, okay, or sometime 1.58, okay, or sometime 1.6, okay, and also sometimes 0.25 millimeter, okay, and the other one is polyimide substrate, okay, this is a biocompatible substrate. It is mostly used in the implantable antennas, okay, it is available of size 0.05 millimeter, okay, point
What is
0.
defined is in the CST.
Yes,
It is in the library, material library in CST.
yes, it is available.
Okay. And for what we use? At what range of frequency?
Actually, polyimide and the Rogers are of same type, okay, not much big difference, okay, polyimide, okay, this one, okay, okay, let's discuss the Roger 3. This is available, okay, and this is also available, okay, it has the permittivity of 11.2, okay, so this is also available, but I think its size is 0.25 millimeter, okay, and other one is the, yes, this one Roger RO4003C, okay, with these values, okay, and other one is the Rogers 5880, okay, I have used this Roger 5870, I have used this 5880, I have used this 5880 LZ, okay, and also this one 6002, okay, and also this one.
Is there no difference between Rogers types?
No difference, just difference in relative permittivity. As I told you in the previous lecture, the epsilon value is inversely proportional to the frequency, okay.
Okay.
So it means if you have high relative permittivity, then it means you need to use the Roger that has the high relative permittivity, like 3010. 3010, where is 30? It has the relative permittivity of 11.2, okay. It means if you have high relative permittivity, then your size of the antenna will be very compact, okay.
Okay. And I think also for the height of the substrate.
Yes, I think it is 0.2 millimeter available, 0.25, sorry, okay. I use only these most of these materials, okay, and there is one more Roger ultra substrate, okay, that is used in implantable antennas. Roger ultralum. Okay, ultralum. It has a relative permittivity of 2.2 and it has thickness of 0.1 millimeter. But it is not easily available, this Roger ultralum. So I use sometimes polyamide or sometimes Roger 5880.
Thank you.
Okay, so do you understand the procedure of this one? I hope tomorrow you have to show me the wideband design, okay? Or it can be ultra wideband or wideband. I suggest you to design ultra wideband. If you are able to achieve, then we can convert it into MIMO, okay, and to target some good journal, okay? Because whenever someone
super wideband. Super wideband.
yes, it can be super wideband, okay, no worry.
Excuse me, Mr. Sarj, could you summarize which the factor that make the antenna ultra wideband is the most important factor, and the range that called ultra wideband and super ultra wideband?
Actually, this is the range of the UWB spectrum, okay? UWB, okay? If your antenna is resonating at more than 11 gigahertz, like up to 20 or 25 or 27 gigahertz, then you can say it is super wideband, okay? And the other thing for the regarding the ultra wideband, how to achieve the ultra wideband, okay? I give you some tips to achieve the ultra wideband, okay? Suppose I discuss this design, okay? And there is a ground plane, okay? Okay, so few things keep in your mind to achieve that may help you to achieve the ultra wideband, okay? The first one is the CPW, okay, that help you to achieve the ultra wideband, okay? And the other thing, like you have a patch like this one, okay? If you add any other patch that is not very closely it is very far from not completely connected with the patch, okay? It is a very you can see here it is connected little bit here, okay? So it helps you to achieve ultra wideband, okay? So this is other thing. And the other thing is that in most of the papers some people have made partially ground plane, okay, on the other side of the substrate, okay, like this, okay?
Actually, it is a common.
Yes, it is very common.
And you can make a cut behind the feed line in the back. The ground structure.
Yes, and some people create slot here like this, okay, or some people cut this ground plane from these corners, okay, like this.
But also the parasitic element can be used also.
Yes.
I don't try it before.
Yes, I have. There is one paper that is very well written. Let me show you. That is published in AEM journal, not mine, but I followed that paper.
Yeah.
I will also send you that design. It is on ultra wideband, okay?
Actually, I was going to go to work in it, but I changed it to the meta material for that because ultra wideband become little old fashion now.
I don't know where is this.
I was collecting a paper of parasitic. I want to work in it maybe 1 year ago, but
yes,
maybe it has no effect.
This paper, okay?
Yeah.
Yes, this paper.
Yes, enhanced, yeah.
They have, you can see the very design is very simple, and they have used small plastic patches here, okay? Plastic elements.
Nice.
And
from which journal this paper?
Journal, this is AEM journal, okay?
EM journal, yeah.
Yes, it is Q3 journal, and it has IF 1.2 greater than 1.2, okay? And it is free journal. Totally free journal. Okay, so you can see it has also used a CPW technique, but he has modified the ground plane. Okay, like this. Yeah, and also this paper is very well written. Okay, and you see how they have used graphs and everything.
Normal shape, yeah.
Yes, and I will share this paper. Okay, you need to follow this paper because it is very well written. I suggest you to follow how to write a paper like this. Okay.
And also, brother, excuse me, could you show me the radiation pattern, the and cross polarization?
Of in this paper?
Yes, I think the result is very nice because you're reducing the cross polarization.
Yes, it is less than 25 minus 25 dB.
Yeah. Yesterday I want to share you, but unfortunately the mic has a problem. Yes, this is a very good result actually. Yeah. But what about the ways about to reducing this cross polarization? Because sometimes it cannot be avoided easily.
Yes, it depends on the structure of your design. You can use it's these pragmatic elements help you in this regard. Okay, you can.
The pragmatic element can help you for reducing the cross polarization.
Yes, if it is
I would
yes, if it is near to the radiator. Okay.
Yeah.
You can see it is near to the radiator. Okay.
Yeah.
So I will send you this paper. Okay, this is good paper and you can follow this paper. Okay. Yes, you can see the design is very simple, no any complex shape. Okay.
Yes.
But if
and I think there was specific shapes under transmission line to achieve ultra-wideband.
Yes, here he just modified this ground plane while the field line is same. You can see. And also I give you one more technique here, like in this paper. Okay, if you add like there is a field line, and if you create a patch that connects the field line here, but it is not a part of the radiator. Okay, so it may also help you to increase the bandwidth.
But the length of the feed line would not have has effect about the matching.
Yes, you can see here he did not cut the CPW from this point. Okay, so it is just for the matching, but here it he modified this because to achieve more wideband. Okay.
No, I mean after we add this additional batch.
This patch.
It may disturb also the main loop. I am afraid about this.
No, it will not affect your matching. Okay.
And what about the radiation?
Yes, it may. Yes, maybe it vary. Your predation pattern may change. Okay. Maybe omnidirectional, or it give you omnidirectional pattern.
Thank you.
Welcome. Okay, so if you don't have any other question, we can end the meeting and be ready for the tomorrow, because I don't want any excuse from you, and I want to see wideband, ultra wideband. Okay, because it is necessary to target MIMO antennas. Okay, if you work on it, then if we can target MIMO antennas too. Okay, because they, in very less papers they use wideband. Okay, for MIMO antennas. Okay, so I prefer you to use wideband, or if you are able to achieve ultra wideband, then it is more good. Okay, otherwise if you only achieve the wideband, then we need to find the novelty factor in the MIMO case. Okay.
Yes. Thank you.
Okay, then we can meet tomorrow. See you.
Do we have a facility in measurements?
In measurements, in my lab we have facility available up to 500 gigahertz.
Which is good enough, sir.
Okay, then see you tomorrow. I am going to end this session.